Okay, hello there. Welcome to my electronics lab again. I'm in the process of building a circuit that will allow me to turn my sweeper on, my shop vac, whenever I have water that's coming in the basement on the floor. I get this here surface water that comes up from the corners, and all I got to do is just keep up with it with my shop vac, and it keeps the surface water down whenever you ever get any kind of bad storms. And I've been doing this for quite a few years now, and I want to make a circuit here now that will allow me to have the sweeper turn on automatically whenever the water hits a probe, and the probe senses the water, and then it would turn on, and it would remain on for a certain amount of time, and then turn it off, and it would just keep on going automatic like that. So here's the circuit I'm working on right now, breadboarding right now, and here is the schematic, and this is pretty much the whole circuit designed except for the front end here. The water probe, I'll have to make something for that, but the relaxation oscillator I have as a switch here right now represented on a schematic, but I do have it built right here. The whole circuit is completed here with the relaxation oscillator and everything. It's just a matter of building the circuit on a printed circuit board now using surface mount components, and that'll be coming up later on. But I'll explain a little bit here how this here schematic shows up here. Okay, let's start from the front end right here. Here's where the water probe is going to be situated on the circuit. And here is where there's going to be a relaxation oscillator. And I'll be able to turn the timing on it that I can go up to maybe a few minutes at a time. And I'll explain why I need to have this oscillator in the circuit later on here. But let's just take a look at the front end here. Here is my AND gates right here, another AND gate. This is an RS latch, an inverter, and then over here is all the drive circuitry that's going to turn on the relay. Let's go back to the front end here and take a look at how this here is situated. What I have going on here is that if there's no water at the probe, the relaxation oscillator will keep on clocking in after so many minutes, checking to see if there's any water at the probe. And that will come in and it will send a signal to this AND gate here and to this RS latch. And at the same time, since this here inverter is on right here, it's keeping this RS latch locked in this position here, keeping the output here off at a low. So what happens is that when I get water at the probe and the oscillator comes in, clocks in, now I have two inputs high that will turn this AND gate on. At the same time, this here will then flip this here. It'll put a signal on the RS latch here, and the water probe will put a signal on this AND gate, the second one, and so now this AND gate can turn on. It also sends a signal down to this AND gate here, one half of it. So now that we have water at the probe and we have the oscillator clocking in, this AND gate is now high. Its output now goes to a high and turns this inverter to a high and makes its output go low. But because I have a diode here, it stops the negative current flow from interrupting this here. This is only to pull positive on here. So now this goes low, this here is now freewheeling here, and so now the high from the oscillator flips this. At the same time, we have these two inputs coming down here. This input into this AND gate here, and the output of this AND gate here also feeds into the other input of this AND gate. And this output now feeds a positive signal over to here, flipping the RS latch over to here, and then it flips over and locks in that position there to a high that feeds back into here. So as long as there's water at the probe and this is high here, this AND gate will be on and it will be a constant loop. When this relaxed oscillation goes off, it's only on for milliseconds and then turns off. It's a very quick flash. When it goes off, the water probe is still high, therefore we have this loop working here. Now with this loop being working here, it sends this here AND gate sends the signal to this part of the circuit here, and I'll explain how this part of the circuit now turns the sweeper on. Okay, so now continuing on here. So now we have water at the probe. the clock signal is off, but because there's water at the probe, everything's looping here, so everything's still working. The signal is coming out of here and going into here. This right here is a Schmidt trigger circuit. It's designed to clock over, to turn on the trigger at a specific voltage. And so when this voltage from this signal here comes in, it trips it over. It causes this to go to a high. This right here is a voltage comparator, so it compares the voltage at its emitter to its base. So now this is going high here, this goes higher than here, and then that causes this transistor to conduct into this PNP transistor, and the PNP transistor turns on this relay driver, and the relay drops in and causes the sweeper to turn on. But at the same time, there is a path going through here to this capacitor to ground. And this is charging this capacitor up to a positive voltage right here. So this is going to give me a delay time here to turn this off later on. So now everything's working here. The sweeper is working and is sucking up all the water. Now all the water is gone, and now the water at the probe is going to be no more water there, so it's going to open up. When that opens up, everything here shuts down immediately. So all this is now shut down, and because this is shut down, the front end of all of this shuts down all the way up to here. All of this shuts down here now too. But because this capacitor is charged up, it leaves a positive voltage, so it discharges through this transistor here and this transistor here to ground, as well as this 10K resistor here to ground. And so as long as this capacitor is discharging through here, it keeps this positive, and this transistor keeps the base of the driver for the relay positive at its base, and so the relay stays on for a delayed time until this capacitor discharges completely, and then the relay drops off, and then the sweeper shuts down. The reason for this delay is so that if there's any water left in the hose, it won't drop back down and hit the probe and just keep on looping. This delay here gives time for all the water to suck up out of the hose into the sweeper, and then it's completely dry, and then the sweeper can shut down. And so that's the schematic of how all this is going to work. Like I said, I built it here, and it works really well. I'll give a little demonstration how this works here on this here, and then I'm starting to work on when my surface mount components come. Here's a small end gate here. I'm going to start working on the surface mount printed circuit board for this. Okay, we're going to do a demonstration here now on the proto board here. What I have here is the relaxation oscillator here, that light blinking there. I can speed this up through a potentiometer here. I can go fast like that. And then I can also adjust the potentiometer and make it go slower. So I'm going to make it go a little bit slower right now for demonstration here. This red LED here, this represents the load, which would be the sweeper on the AC relay, a DC coil to run an AC load. And then over here, I'm monitoring the amount of current that this circuit's taking. Under idle conditions, it's running about 70 milliamps. I'm designing this so they can work off a 9-volt battery. Okay, so what we're going to do now is we're going to simulate water at the probe here. Whenever I connect this to here, it's going to simulate water at the probe. Now, when this clocks in, that green light comes on, everything will turn on. Okay, so the green light came on and everything's turned on. The capacitor is charging up, and now under the conditions where the sweeper is now running, we have about 240 milliamps of current that the circuit is drawing right now. Now that's the capacitor charged up there. So now as the sweeper sweeps up all the water, the probe then becomes empty. The water off the probe becomes dry now. So now this light turns off, and now we have a delay here. As you can see, the capacitor is discharging, and as it's discharging for the delay, then it turns off, and then everything's ready to be set for another run again. As I said, this here is right now prototyped with the large components here, but I am going to put this on use surface mount components and to put on a small board and to put in a nice little case. I just want to show where I got so far on this design, and next I'll show about doing the printed circuit work, and then we'll see how the whole thing comes together and how it all works together. Okay, thanks for watching. Bye.